Greetings of the day, dear students. In this video, we are going to discuss about the earth leakage circuit breaker. In the previous videos, we have seen about the fuse element and a circuit breaker MCB, right? Here, we are going to discuss about the earth leakage circuit breaker. What are the different types of earth leakage circuit breakers we are having, like voltage earth leakage circuit breaker, current earth leakage circuit breaker, current ELCB, and their operation, its diagram, all those things we are going to discuss in this video, right? Dear students, if you observe our previous protecting elements like fuse and circuit breaker are not going to protect the human beings or the operators from the electric shock, right? If there is any amount of leakage current passing through the electrical equipment, maybe it is a motor or some fan or some refrigerator or AC, whatever might be the electrical equipment, if there is any amount of leakage current passing through the equipment, then it leads to the shock. When a person touches the equipment, then he will undergo the shock. Now, the magnitude of shock the person can experience will depend upon the resistance of the human body and the amount of magnitude of voltage difference that is existing because of the leakage current, right? And the duration for which he is exposed to the voltage. So these three parameters are going to decide the amount of shock, the magnitude of shock the person is going to experience. One is his body resistance, right? The resistance of his body. Again, it depends upon whether the body is dry skin or wet skin. Depending upon whether it is a dry skin or wet skin, the resistance of the human body will change, right? If it is a dry skin, at 230 volts, some 3 to 3.6 kilo ohms of resistance can be observed. And if it is a wet skin, for the same 240 volts, the amount of resistance offered by the human body will be less. It is around some 1 to 1.2 kilo ohms. Obviously, when the resistance offered is low, the person is going to draw the more current and is going to experience the shock severely, right? So here, depending upon the body resistance and the magnitudes of voltage and the duration for which or for how much time period he is exposed to the leakage voltage difference, all these parameters will decide the amount of shock, right? In order to protect the human beings or persons or operators from the electric shock, these earth leakage circuit breakers are utilized. These earth leakage circuit breakers are utilized. They are going to sense, they are going to detect any leakage current present in the equipment. In order to do so, we are having two types of equipment, two types of earth leakage circuit breaker. One is the voltage earth leakage circuit breaker, and the another one is the current leakage current earth leakage circuit breaker. Coming to the voltage earth leakage circuit breaker, this is the diagram you can observe. Here you are having the supply terminals. One is the phase terminal and another one is the neutral terminal, which are connected to the load, right? And the load is also going to have a neutral terminal and the phase terminal. Now this circuit breaker is going to have a relay coil, which is one end of the relay coil will be connected to the ground and another end of the relay coil will be connected to the metal body part. That that metal body part can be of either, it can be a body part of a refrigerator or motor or some AC or air conditioner or whatever might be the equipment, oven, fan or whatever might be the equipment. Its metal body will be connected to this terminal, to the other end of the relay coil. Now, as and when due to the passage of the leakage current, there exists a voltage difference between the two terminals, right? Now this relay coil will sense the voltage difference and based on that it will trip the circuit. It is going to trip the circuit, right? So here it is going to contain a relay coil and one end of the relay coil will be connected to the metal body as I told you, and the other end will be connected to the ground wire as just now I have shown in the figure, right? If the voltage of the equipment of the body rises, it will cause the difference between the earth body and load body voltage. If there is any voltage difference between the earth and the load body, that voltage difference will lead to a dangerous electric shock, right? Now this voltage difference is going to produce an electric current from load metal body and phase and through the loop to the earth loop, and through the loop to the earth it will pass through in that manner. Meanwhile, if a human person touches that body, he will undergo the shock, right? So when voltage on the equipment of the metal body rises to a danger level, so if it exceeds some 50 volts, right, then the current flowing through the relay loop will move the relay contact by disconnecting the supply current in order to avoid any dangerous electric shock. Like this, the relay gets operated. If there is any voltage difference is existing, then the relay contact will disconnect the supply current, and it will prevent the human beings from the shock, right? Now the ELCB, it is going to detect the fault currents present from line to earth, that is the ground wire. Within the installation, it protects, because for which equipment you are using this circuit breaker, for that equipment only it can get operated. It is not something like for all the devices or equipments this one single equipment is going to serve the purpose. Each equipment, from which equipment the person is to be protected, there only it is going to function, right? So here now, if all this gets operated depending upon the voltage difference, if the sufficient voltage appears across the earth leakage circuit breaker sensing coil, it will switch off the power and will remain in the off state until it is manually reset, right? So this is about the voltage leakage circuit breaker, and it is going to have a relay coil, and it is going to one end of the relay coil will be connected to the metallic load body, and another terminal will be connected to the ground wire. Depending upon the leakage current, depending upon the potential difference, right, it gets operated. Now coming to the earth leakage circuit breaker, it is going to have a 3-winding transformer, right? 3-winding transformer, in which 2 will act like a primary winding and 1 winding will act like a secondary winding. We are going to have a 3-winding transformer. Out of those 3-winding transformer, 2 will act like the primary windings and 1 will act like the secondary winding. Now if you observe in this diagram, the coils, that is the winding that is there in line and neutral, will act like the primary windings, and the coil that is there here connected to the relay will act like the secondary winding. This acts like the primary winding, this acts like the primary winding. As long as there is no leakage current, the same amount of current must flow through the line and the neutral. For example, through the load, if 5 amps is entering, if there is no leakage current, then at the leaving terminal also there should be 5 amps. Then at that case, there is not there any amount of leakage current passing through the equipment. But if the entering current is some 5 amps but the leaving current is not exactly same as incoming current, then obviously there is some amount of leakage current passing through the equipment. As and when there is some current difference between the 2 primary coils, it leads to the induction of some voltage, right, and corresponding to that current difference, some EMF will be induced in the secondary coil, and based on that, depending upon the magnitude of voltage induced in the secondary coil, the relay gets operated, and it is going to sense that difference in the voltages and currents, right, and based on that this relay is going to give the trip signal. As long as the current flowing in the line and the neutral are same, there won't be any sort of any sort of leakage current. If there is any difference, that will be sensed by the sensing circuit, and the relay will get operated and it will give the trip signal. So it will disconnect the source from the load. It will disconnect the source from the load. Like this, depending upon the windings of the transformer, where we are having the 3-winding transformer, 2 acts like the primary winding and 1 acts like the secondary winding, it gets operated. So this is the diagram. Right? So dear students, in this entire discussion, the types of earth leakage circuit breakers, their diagram, their operation, and how it is going to protect the human persons from electric shock, what could be the resistance of the human body during dry skin condition, during wet skin condition, and what is the magnitudes of voltages they can withstand a human body, right? For how much time period the human body can withstand, how much amount of magnitude of voltage, all those things will be decide the magnitude of shock the person can experience, right? Thank you.